the extreme height of the other beta beta, and the other two are actually beta alpha and alpha beta, and these are the four energy state of scalarly coupled CH carbons. इसमें कोई प्रॉब्लम तो नहीं है? Do you have any problem in understanding this? No? Molecular medicine student. Do you have any problem in understanding that when you have a carbon and a proton scalarly coupled, when they are coupled together, they are influenced by each other and they share the energy levels. And this is the reason why carbon coupled to a proton appeared as a doublet. And this is the reason why proton coupled to a carbon appeared as a doublet also. If they are not sharing the energy levels, they would never appear as doublet, because the energy transfer only takes place when they have a shared energy level. So it's a very simple diagram of a couple and more precisely a scalarly coupled proton carbon carbon system, a CH system. Now this is the one from where the difficulties start appearing in the understanding level, and I'm not really sure that why it was difficult for us to understand, because these are spin half nuclei. So this is a spin half gamma H and this is a spin half gamma C. On the other hand, these would have a different orientation, so they are negative half gamma H and negative half C, right? In this case, one would be positive and the other would be negative, and this would be negative and positive. So if you see that there are four different transitions: single quantum transition. Single quantum transition means when you have one spin switching the orientation. Always remember, single, multiple, double quantum, they are not very scary. They look very scary words, but they are very simple words. From here to here, this is a single quantum transfer. Single quantum transfer means that one of the orientation has changed, and in this case the orientation of carbon has changed, right? Right? Okay. From here to here, there is orientation of one spin change, and there is also a single quantum change, and this is again a carbon, right? So these two energy levels belong to carbons, and here to here there is a change of orientation of proton. So this is a single quantum transfer of proton, right? And this is a proton levels too. From here to here, this is the transfer of only single quantum, and that is proton, right? So this is again a transfer of the spin orientation of one to the other in case of a proton. So remember, this is a very, very simple system, and one understand it very very simply. In this case, if you forget the natural abundance and if you just remember the gyromagnetic ratio, you would know that the carbon signal would be 1/4 of for proton. So forgetting the natural abundance would actually help us to understand what is the sensitivity level would eventually be achieved. But now it looked fine to me, and we can proceed further. But before proceeding further, you can very easily add plus half gamma H plus half gamma C to all of them. So try to understand that is a very simple equation, because half looks rather difficult, so you just add a very common factor to all these energy level, and that is plus half gamma H and plus half gamma C. What it would become? Gamma H and gamma C. What it would become? Gamma H. And this? gamma C, and this? God, you're so intelligent, you know. So this is what actually happened. This is plus half gamma H plus half H, and that's what you have predicted. Very simple. Now, in order to understand the population, one need to have numbers, you know. Even population difference, the Boltzmann distribution axis is actually numbers. And without having numbers, it's very, very difficult to understand the intensity enhancement because of a selective action. So if anybody has a problem, I think we go back to this. We add a factor plus half gamma H and plus half gamma C. This become 1 gamma H and 1 gamma C. This become what? Gamma H, and this become gamma C, and this become 0. And this is a very simple version. Now if I tell you that the population difference, forgetting the natural abundance, the population difference between proton and carbon is 4:1 based on gravimetric ratio. So gamma H is 4 and gamma C is 1, and this become what? And this become 4, and this become 1. Now this is the energy state, which is a normal energy state, because you didn't really do anything. You have not really added any selective population version, or you have not done any type of intervention in the process. Now if I tell you that the intensities would look like this, that the proton signal would be 4 times larger than the carbon doublet. So this is a proton doublet because of the coupling with the carbon, and this is carbon doublet, and it is fairly simple because you can calculate that 5 minus 4 is 4. This proton signal 5 minus 1 is 4, and 4 minus 0 is 4, and this is 5 minus 4, 1, and this is, and that's what you see, right? This is the normal without any polarization transfer, forgetting, ignoring the natural abundance. This is the population which you would be able to see. Signal. Okay, so we move forward, and we go to this stage, and this stage is the stage in which we do a very selective population inversion, called SPI. And this SPI, which we will try to understand again, is a beautiful, nice way of transferring population from one state to the other state. For simplicity, just assume that one of the two lines of the proton is inverted, right? Which primarily means that you take this population up and this population, and when you do that, the population difference between the carbon is also affected, isn't it? When you do that, it's not, although this is a selective population inversion in a proton level, but since they all share the energy levels, the population difference between carbon would also be affected. Okay, and what it would be eventually, and it would be like this. When you would have 4 transferred to the highest energy level and 0 on a different energy level, the difference between the population of proton would be 4 minus 4, because you have inverted one of it, right? Inverted one of it, and the other, the carbon-13, which share the population polarization with the proton, would be plus 5 and minus 3. इसमें कोई मसला तो नहीं है? It's so easy, right? It's very easy, because 5 minus 0 is plus 5, and 1 minus